Today we're gonna build the coolest DePin project we have built so far. It's gonna be a decentralized bar. I scan this QR code with my Solana mobile wallet. I connect my wallet and I approve the transaction. And this pump will immediately pump us a drink directly out of the bottle into our glass. How cool is that? Today I'm gonna show you how to set this whole project up from beginning to end. So we're gonna assemble it, I'm gonna explain you how it works. And you can build this whole thing for under $100. So let's get started. So DePIN stands for Decentralized Physical Infrastructure, and it's a hot topic on Solana right now. And we have the Solana DePIN Examples, where you can find a bunch of different examples that you can play with. So we have this LED switch where you can switch an LED on and off with QR codes. We have the Solana bar example that we're gonna go through today. Then we have a helium LoRaWAN sensor. LoRaWAN is similar to the mobile net, but very low power and high range. Then we have ESP32 Solana tracker with display. We have a hardware wallet that you can build yourself. And then we have another example where you can write sensor data on chain. So you can, for example, have like weather data or earthquake data or whatever and write it directly on chain. And then we have LED display example that shows you how you can just show stuff on a small display. But today we're gonna go through this bar example and I want to explain you how it works. So it's decentralized physical infrastructure because everyone can just like buy a bottle, put this head on, and then you can put it in a bar and sell drinks. So basically you can buy a bottle of Jägermeister and then you can sell each shot for $1. And then if the bottle is empty, you probably made some money in the end. So, and everyone can just build it. So it's decentralized, you just put it somewhere and it will work. But how does it work actually? So the main piece of this is actually an app, a web app. And this web app is connected to a Solana program that is written in Anchor. And what you can do here is you can set up your bar. So let's check out this Solana bar. And here we can see we have two products. So we have a shot and we have a Jägermeister. And then we also have a setup for this bar. So I can add new products here. I can see all the recent receipts. And I can also configure a Telegram notification channel. So I just put the channel here, and whenever someone buys something, then it will automatically be written into this Telegram chat. So you could theoretically use this to set up a complete bar or restaurant. So you just print out a few QR codes, put them on the table, and then the barkeeper would just get these notifications. Someone ordered a Jägermeister on table 1, and then you could bring it to him, or you could just let it dispense itself using the RaspberryPi. And that's what we're gonna do today. So this is the whole setup here. So basically we have this web app where you configure your program, your products, and then whenever you select a product, you will get these QR codes here. These are Solana Pay Transaction requests. And these transaction requests, basically, when you scan the QR code with your mobile wallet, then your mobile wallet will do a GET request to your backend. This one is deployed in Versal. And then it will give you the icon back and the product name. And then the mobile wallet does a POST request. And then your Versal app actually creates the transaction. So in this case, it would be purchase 1 Jägermeister table 1. And then the mobile wallet gets the transaction and it signs the transaction and sends it out. And then what our Raspberry Pi with the little pump does, it has a WebSocket connection which is listening to this account constantly. And as soon as the account changes and there's a new receipt, then the Raspberry Pi will trigger the little servo, press the button, and as soon as the drink is dispatched, it will actually write a transaction on chain and say the drink was delivered. So that we can actually see here, the shot that I bought in the intro is marked as delivered. So that one we purchased, it was delivered, and then the Raspberry Pi wrote a transaction to set it delivered. But these Jägermeisters here I bought earlier, because they are not configured on my bar, so they were never delivered, they are still in pending state. And this Telegram post notification thing here, so there's another API within this Versal app, which has a Helios webhook that is also listening to this account. So whenever this account changes, Helios is calling our API and says, hey, there was a new event. So in the Anchor program, we dispatch these events. And when there is a new event, then it will call our API. And the API has configured a Telegram ID And then it will just post the message of this event into the chat. In this case, it will be table 1 ordered 1 Jägermeister at the current time. And yeah, so this is how the whole thing works. It's easier than it looks actually. You can also see here a video, how it looks like, and this is all the things that we need to build it. So yeah, let's assemble the whole thing. So these are the ingredients that we need, and now we're gonna flash our SD card, and then we're gonna assemble the whole thing. So I'm gonna put this SD card directly in my computer, and then I'm gonna show you all the things we need while this SD card is flashing our operating system. So we're gonna use a Raspberry Pi 02WH. So this is a Raspberry Pi 0 here. And this one actually needs very little power, but it's still kind of powerful. So it has like 1 gigahertz and 512 megabytes of RAM. So it's perfect for our project. Then we're gonna use the Raspberry Pi OS 64-bit, and we're just gonna flash our SD card. And now it's gonna ask us what we want to set up here. So I'm gonna call this one bar 4. So I already put a little 4 on my Raspberry Pi so I don't get confused. And then I set up the Wi-Fi already that I have here in my flat. And then you also should enable SSH here. So we save this and we flush this on our SD card. And while this is running, I'm gonna show you all the things that we need. So here on the screen, on this desk, we can see actually everything that we need. So we're gonna have to build a very small version of it. We're just gonna add a display, and we're gonna add a servo to press the button. And if you want to add sound or a bigger screen later, there's also a tutorial in the README further down. But so what we're gonna have here, this is like a little display. So it's an OLED display with a resolution of 128 × 64. Here we're gonna show the product that you can buy and the price in USDC and the bar name. Then we have here the Raspberry Pi 0. Then we have here, this is a power solution. It's called Pi Sugar. This is just so that we can easily attach the Raspberry Pi, and yeah, that we don't need a constant power supply. So you don't always need a cable. So you can actually carry it around in a bar, and it would also work outside if you, for example, connect it to a mobile hotspot to your phone. Or like, yeah, there's also these hotspots like Local Me that you can use everywhere. I'm gonna show you a few other things that you can use for the mobile connection at the end. So this we need to do, and then we have the servo. The servo will press the button on the pump, and then we have the pump here. So let us unpack this. So this I ordered from Jägermeister actually. And this one is nice, because you can just press the button and it will immediately dispense you 1 shot. So it's very easy to use. You just press it and it works. And now we're gonna attach this Raspberry Pi to our power solution. So this one will power the Raspberry Pi for a few hours. So I need a little screwdriver as well. So I'm gonna screw this in here. It's good because the flashing of the SD card anyway takes a bit. So I'm gonna screw this one in. So I'm gonna screw this in. Need to make sure that the pins are properly aligned here, because these pins are actually powering the Raspberry Pi. So I'm gonna screw this in, the 4th one. And then we're gonna attach the cables. This is in here. And in the meantime, we can check the progress on our imager. So it's verifying already. So we need to be fast here. Okay, so this looks good. And now we scroll down a little bit here in the README and see how we need to connect this. So here we have the pins of the Raspberry Pi. And the first thing we want to connect is the servo. So I fittingly have the right color of cables here actually. So we have brown, red and yellow. And the brown one needs to go to ground. The red one needs to go to 5 volt, and the orange one will be our control pin. So that's the one that we set for a short while to press down and then press up again. So we need to connect this one. So the brown cable needs to go to ground. So for example, pin number 6. So we put this one here on pin number 6. And then we put the power onto power. So this will be the second one. And the orange one we need to put to GPI 14, which is pin 8. So this one will be the one directly below it. So now our servo is already connected properly. So it just needs 5 volt and then it will be controlled via the orange pin. And now we want to connect this little display as well so that we can show the bar name. So for the OLED display, we need to put VCC to 3 volt. 3 volt is on the top left. So for that, we're gonna use the red wire. So here we can see VCC is the second one. So we put this one on the top left. Then we have ground. Ground is this one. And ground we connect to pin number 6. Pin number 6 is already used, so we're gonna use 1, 2, 3, 4, 5. We're gonna put it at 1, 2, 3, 4, 5. So this one is also connected. And now we need to connect SDA to pin 2, this one, and SCL to pin 5. So you can already see here it says SDA and SCL. So let's connect that. So the first one is SCL. Who remembers where this needs to go? SCL goes to pin 3. 1, 2, 3 here. It's a bit small. Like I used smaller cables now because I thought maybe it's nice if we have the whole thing a little bit more compact. Because on the first bar that I built, the cables are very long and then it looks very unprofessional for some reason. So, and now we put SDA here. So this will be SCL and the last one will be SDL. So now this is already correctly set up. So we have the servo and we have the display. Let's see how far our Raspberry. So the writing was successful. So now I'm just gonna take this one out and I immediately gonna put it back in again because I want to configure the bar. So what we will do is we open this up. And now we're gonna copy some files onto the SD card so that we can easily set it up. So now I checked out the repository and now I'm just gonna copy over the Raspberry Pi folder directly onto the SD card of the Raspberry Pi. So I'm just gonna copy and paste. And now we have this copied over and now I'm gonna change the bar config. So here we have a bar config. And here I want to just set a few things. So Jonas bar is correct. But for the product name, now we want to actually sell Jägermeister. So I just put Jägermeister here. And now off screen, I will also add a RPC URL here. You should use a good one because you need a proper WebSocket connection. And then I'm also gonna add a private key, which will then set all the drinks as delivered once they are delivered. This is kind of optional, but I think it's kind of cool that you can see that the Raspberry Pi is actually saying that he actually delivered the drink after the pump started. So now I've set up everything. So I added the RPC URL and the private key, and then I took the little SD card, micro SD card, and put it into the Raspberry Pi and started it. And now we need to see if we can actually find it in the network first. So we're gonna do ping bar4.local. For you, it might be ping.pi.raspberry.local or something like that, whatever you set up in the display, in the configuration in your Raspberry Pi imager. So that looks good. So we can already ping it. And then we can also SSH into it probably. So I set up username bar, so bar4.local. And yeah, now we have an SSH connection into the Raspberry Pi. So now we can do things there. And now we're gonna, first we need to remove this one from our known hosts because I did this earlier already. So here in the known hosts, I just delete the old Raspberry Pi because I had it set up before already. And now if I do SSH, now it asks me if I want to create a new key. And now I will be able to log into it, hopefully. So now with the correct password, it will work. So now we are actually in the Raspberry Pi. And now we're gonna go through the README for the Raspberry Pi setup. So there's just a few things that I would recommend you to do. So if we want to, for example, use the display here, we need to enable the interface option, E2C. So I'm just gonna enable that one. That one is now enabled. So now we will be able to actually use the screen interface. And yeah, now we're just gonna run this install script here. So you can also do this completely manual, of course, if you want. This install script, what it does, I can show you. So it will create a service which starts the bar service at startup every time. And it will install NPM. It will install TSX globally, and it will also change the swap file size to be a bit bigger, because I noticed whenever you want to work on the Raspberry Pi directly from cursor, you quickly run out of memory because JavaScript is like not super memory efficient. But the nice thing is if you just go here on the bottom left, you can just do a connect host, and then you just put SSH, your Raspberry name, and then you can immediately like from your computer work on the Raspberry Pi without like copying files over or needing a monitor to work on the Raspberry Pi. So that's very comfortable, but it works better if the swap size is a bit bigger. Yeah, this now takes a while, so it like installs npm and then it goes into the bar folder and then installs all the dependencies in there. In the meantime, I can already show you this this bar script here. This is basically what is running on the Raspberry Pi and is doing this WebSocket connection to listen to account changes. So whenever someone buys a drink, the Raspberry Pi will see, hey, there's a new receipt in that account. And then he looks if it's already delivered, and if it's not delivered, then he will deliver it and write on chain that he delivered it. So yeah, we have some imports here. So we have we need the OLED 12C bus for the little display here, and then we have the bar config. So that's we load from this txt file from the SD card, where we have the bar name, the pump duration, the product name, the RPC URL, and the private key. Then we load all this config. Then here we just clear the display, here we load the private key, then here we create the anchor program, and the anchor program we need in the end to mark a purchase as delivered. And here we subscribe to the account change. So we just say, hey, connection on account change for our receipts PDA. And the receipts PDA will be just derived from the bar name and the product, the bar name and the program ID. So like this, you can like for every bar, if you configure a different bar name, the Raspberry Pi will listen to another bar and another product. And yeah, when there's a new update, so this is basically how we draw a little Solana logo on the screen, just because it looks nicer. And yeah, here we fetch the receipts account, and then we see here if there's a receipt that wasn't delivered and fits to our product name, so in this case it would be Jägermeister, then we will pour the shot and mark it as delivered. And in pour shot, what we do, we first we write the MP3 player. This is another GPI open, so if you want to have a sound whenever someone buys something, then you can also have one pin on GPIO 23, and otherwise we just press the button, and press the button is servo right press position. So this will be, I don't know, like 20 degrees, and then it will go back. And then with that we can press the button on this pump here. So as soon as this script here starts up, we will also actually attach this whole thing to this bar here, and then the product will be already done. This is how we mark the shot as delivered. So here we just call the program mark as delivered with the bar name and the receipts ID, and we sign with our wallet here. Currently, everyone can mark shots as delivered, so we could theoretically change the program so that you can actually configure an authority or like a mark as delivery authority or something. But yeah, if any one of you wants to build a proper product out of this actually and like make this a bigger thing, this would be a good starting point. What you could also do is like add the proper name of the bar or the address and all these kind of things. So there's lots of improvements here. But yeah, this script is done. So now we're just gonna wait for this installation to finish. And then we will assemble the bar here. So now the installation is finished. So this ran through and we can see that the display is already showing the correct bar name and the correct product name and the price. And we can also see here in our bar setup on letmebuy.app that one of the Jägermeisters is already delivered. So now if we buy another one, so we go in here, we buy a shot and we just buy it here with our browser wallet. Then we should be able to see that this works. Oh, we need to approve. So we approve this and we can see it presses the button and then there is also a little flashing on the screen. So now we can actually attach this. So now I'm just gonna take a little bit of this magic tape here. And we're gonna glue this on and then the bar is already finished. So this tape is nice because it's very flexible but still very strong. So I'm just gonna put this here on the side of the button. And now I forgot in which direction the servo moves. So I'm just gonna buy one more. So it's moving down. So I'm just gonna press this on here. And then we're gonna put this this Raspberry Pi here at the back or on the side, maybe on the back. So I'm just gonna take a little bit more of this magic tape here, just a tiny bit, and we're gonna glue the Raspberry Pi on the back of the pump. So I'm gonna put this here on the back and we're gonna put the Raspberry Pi here, zuck. So this is glued on. And now we also want to put the display on the front. So I'm gonna take another little bit of tape. And then we put the display on and then we are done. Then we have a decentralized bar. All we need to do then is to print this QR code as well. So I'm gonna put this here on the front. And then we're gonna glue the display on. So I'm just gonna put it like this. And now we have a proper decentralized bar. So we have the Raspberry Pi here, we have the pump, and we have the button which presses the pump. So now I put it into water. And now let's see if we... By the way, I'm also getting like constantly these notifications in the Telegram channel, because every time we buy something, we get a notification. So we buy this, it presses, and we can see that it's not pressing down enough. So actually we need to remove this once more and change the servo position a little bit. So we're just gonna take this one off and put it a bit further down. And so now it should press the button properly. So I'm gonna buy another one. Almost there. So let's put the button here and it's working. So now it's working. We just need to like find the proper position for the servo, but we can see it's pumping. So now we built our own decentralized bar here. It's quite nice. We just need to like find another a better position for the servo to put on. But yeah, so now we built our own decentralized bar. So now I added a little screw here. So now it's actually fixed. So now if I buy a few of these, we can see that it properly presses the button and it pumps. So and now it works. And now I'm gonna explain you a little bit more about how this thing works. So the whole project is set up in 3 different parts. So we have the app, that is basically this app here where you can like create these QR codes and set up your own store. This one works like this. So we have this app folder here, and then we have store/store name. So depending on which URL you put here, you will have different pages for setup and the storefront, depending on the bar name. This is a versatile feature, like a Next.js feature. And then here in the setup, we just have the different parts where you can, like here you can define the different SPL tokens, for example. And then here we have the anchor program, the IDL. So we fetch the receipts and then we show them in a list. And then here on the store page, we have the anchor program again, and we are creating these QR codes depending on which project you have selected. So we set the selected project whenever you change a product, and then when we go to selected product here in the list, then we will see that we actually create different QR codes depending on which product is selected. So here we have the purchase notification that is coming in every time you buy a new product. And then here we have the logo. Here we have the either if the store is initialized or not yet initialized. Then we have the link, and then here on the bottom, here we have the currently selected table. So you can also have like different products per table. And then here we have the QR code. So we have our instruction for the QR code, which in our case will be a buy shot or make purchase or something like that. Then we have the store name, in our case will be Jonas Bar, and selected product will be Jägermeister. And then we have the price, and we have the product decimals. So this is basically the decimals of the SPL token. So for example, if you have USDC, it will be a decimal of 6. And then if we go into this QR code component, here we can see it just takes all the stuff that comes in and it creates basically a URL from it. And this URL will be encoded into this QR code. And then when we scan it with our wallet, then our wallet will do a GET request to our app. These ones you can see here. And this one then returns the logo of the app. In this case will be Let Me Buy logo and the name of the product. And then afterwards the wallet, your mobile wallet, will do a post request here. And with all these different instructions. So the instruction, the product name, the store name, and the table number. And this one is then used to create a transaction. So here we get the associated token address of the user, and then we create a make purchase transaction with the store name, the product name, and the table number. And this transaction is then sent to the mobile wallet and will be signed. This is basically the whole magic of Solana Pay Transaction requests. It's these two requests here. Then we have this webhook. So this webhook is actually used to send the Telegram messages into a Telegram chat. And I think I'm gonna make a more in detailed video how this works. But basically how it works is we have in the program, we emit an event. So if we go to the program, and then here on the top we have the purchase made event. And this one will be emitted every time someone does a purchase. And then in Helios, we can create a webhook. And this webhook here, it looks like this. So it's calling our Let Me Buy API webhook. And whenever this one changes now, we get all the messages that, all the transactions that include this program. And then in this API, the webhook, webhook tg.ts, this one will be called by our Helios webhook. And then what we do is, here we have a test message. And yeah, what we do is we take the transaction signature and then we use the helper function pass anchor transaction events. This gives us all the events from this transaction. And then if it's a purchase event, then we post a message in Telegram chat. And now, yeah, so I will make a more detailed video on how anchor events work and how you can use it for a Telegram message, for example, or for anything else. And yeah, then we have the Raspberry Pi part that we already talked about. And then of course we have the program. And the program is actually very simple. So there's not much in it. There's the event, then there's a bunch of errors, and then we have an initialize instruction. Then we have update Telegram channel, so you can configure your Telegram channel. Then we can add new products, we can delete products, and we can make a purchase. And make purchase thus puts a new receipt in a list of receipts and then emits the event. Here, emit purchase event. And then the Raspberry Pi can listen to this one and our Helios webhook as well. And yeah, then this is how the whole thing works. And then the Raspberry Pi can call mark as delivered with the receipt ID, and then the drinks will be delivered. So yeah, I think we are going to like reaching the end. So let's buy one more of these here. Let's see if it works now. So our bar works, and we build it like in just a few minutes actually. So you can build your own bar, and you can use it for many other things as well. So you could, for example, now make this bar even better. Since it's like maybe a little bit risky to have the QR code like glued on top of the bar like I have with the other bar, you can also like use a bigger display and then immediately show the QR code on there. So for example, this would be an e-ink display, which could work very well. And then there's also bigger displays of these OLED displays that you could use. Or just like a smaller display, which is also an e-paper display. The nice thing about e-paper displays is that they use very, very little power actually. You could control the whole thing with LoRaWAN. So for that you could buy a loop cell HTCCAB02S. And with these things you can actually use your LoRaWAN network to control the servo. And yeah, then it would basically use the Helium network to control your decentralized bar. I also am gonna make a more detailed video on how that would work, but basically what you can also do is in the Things network, you can use the LoRaWAN nets to do a downlink to one of these loop cells here. And these are super nice dev boards. So you can see they have like a little display already and an antenna. And yeah, but like this, you could probably run this everywhere without even needing Wi-Fi. But if you want different Wi-Fi solutions, so what you could also do is you can connect your Raspberry Pi to just one of these mobile internet sticks. And you basically just put this in here, and usually it automatically recognizes the USB stick and connects. And then you just need to put a SIM card here. So I used one from Aldi Talk here in Germany. It's like a very cheap one. And yeah, that one works well. But what you can also do, which is also really cool, is you can use one of these Raspberry Pi 4G heads. So this you could also put on the Raspberry Pi and then put an SD card directly in there and connect it to your Raspberry Pi, and then you should also be able to have basically internet everywhere. And this one, I didn't attach this one because it needs a lot of power, and then probably you wouldn't have enough power anymore to have this running for a few hours. Another solution that you can use, which I used for one of the other bars, is you can use one of these USP systems. So here you put in a quite big battery with 3300 milliamps, a lithium ion akku. And with this one you can basically run the Raspberry Pi Zero for many hours at least. And yeah, so that one also, this one works very well. It's very simple. And then there's different pump solutions. So for example, there is this pump here. I posted a link to a few different pumps. The nice thing about this pump is that when you press it once, it will stay on. So with this one, actually, you could like have bigger drinks dispensed, like wine or whiskey or something like this. And yeah, now it's on you to experiment, basically. So what you could, for example, also build here is you could build decentralized jukebox. So one of the examples uses also an MP3 chip and a 3-watt speaker. And with this, you can also play music. So whenever you buy a drink, for example, you could also play a nice song or like say Prost or whatever. So that would be really cool. And then if you make it a jukebox, you can, these MP3 chips work like this, that you just put a bunch of songs directly on an SD card and put them in there, and then you can play them. So what you could do is you could have a book with QR codes where every song costs like, I don't know, 10 cents or 5 cents, and then you play the song. So you could build your decentralized karaoke machine, which would be really cool. Or you could improve this one like with the bigger screen, with the better internet connection, because currently you always need to set up the Wi-Fi. But yeah, I hope you're gonna experiment with this, because I think it's so much fun, and it's like it would also be a good project for the hackathon actually if you build something like that. And yeah, I hope I'm gonna see you in the next one. Please ping me on Twitter if you build something cool, and if you want to see more of these kind of hardware videos, let me know and subscribe to my channel. And yeah, see you in the next one. Bye bye.